Hello students, today we are going to see one of the problems that has been given in the model paper. So the first question was we have to see what is define the inner product space, and they have given a question. So what is inner product space? The pair of the vector v with the inner product is called inner product space or vector space with inner product. What does it mean? It is similar as to say that it is nothing but with a set v with the inner product. Okay, that is inner product is with the symbol inner product of dot comma dot into inner product. So if I say only in inner product, then it is represented with the symbol that, and if I say that it is a space, then it is a set of the vector and the inner product. All right, so that is inner product space. Now let us see the example, the question they have asked. So with the consider f of t, g of t they have given, and the polynomial space p of t with the inner product, and we have to find the inner product of f of g, f comma g, and the magnitude of f, or I can say it as a norm of f or norm of g or a magnitude of g. Okay, everything is same, one and the same, so you have to see, don't get confused with the terminologies. All right, the first and foremost thing, we will find out what is the inner product of f comma g. So they have given that it is f of t into g of t with the interval from 0 to 1. So directly we will find f into t into g of t first, and then we will apply to the into the integration. So it is 3t minus 5 into t square, so you will get 3t cube minus 5t square. So I will apply this to the integration. So I'll get 0 to 1, 3t cube, so 3t cube minus 5t square, so dt. Once I apply the integration, it is 3t to the power 4 by 4 minus 5 t cube by 3, interval from 0 to 1. So if I apply the, it is always the upper limit minus lower limit, right? Integration. So it is nothing but it is 3 by 4 minus 5 by 3. If I apply the lower limit, it is equal to 0. So I'm directly applying it, so it is 0. So I'll get the answer as minus 11 by 12, right? So I got what is that if I try to apply it, so f comma g is inner product of f comma g is minus 11 by 12. So what is norm of f is the formula for what is the formula? It is root of inner product of f comma f. Instead of g, you just apply the f. All right, so it is 0 to 1. So what is f? 3t minus 5 the whole square, right? It is f comma f, that is why whole square dt. Now I will solve only for f comma f because it will be easy for me. Always carrying the root is difficult. So it is so I'll write it down, whole square dt. So what I will get if I open the integration, so I'll get the answer as 90 square minus so it will be what 225. Sorry, what I will do is now I will apply the a minus b or the whole square formula. So it is a square minus a square minus b, a square plus b square minus 2ab, right? So I will apply that. After that I will open the integration. I'll get 3t cube minus 15t square plus 25t, so 0 to 1 dt. Okay, I will just take the reverse form, so please note down. So okay, I'll solve it with the upper limit. So I'll get 3 minus 15 plus 25 minus the lower limit 0. So I'll get the answer as 13. So that is f comma f. So what is the norm of f? Norm of f is what? It is norm or magnitude of f is what? It is root of 13. So I got the inner product. Now I'll go for the inner product or the norm of g. What is the norm of g? It is root of 0 to 1. It is t power 4 dt. So I will take only the inner product g comma g, which is what in a 0 to 1 t power 4 dt, which I'll get as t power 5 by 5, 0 to 1. So upper limit minus lower limit, right? So it is 1 by 5 minus 0. I'll get 1 by 5. So apply the norm, that is g comma g comma g is what? 1 by 5. What is norm? Norm is nothing but it is root of 1 by 5. I can also write it down as it is 1 by root 5. Yes. Okay, the next topic is orthogonality and orthonormality. So we have to understand the definitions, and the probability of asking the definitions in the exams are more. So we will see what is orthogonality and orthonormality. The difference is very minute. So I've written it, side by side so that you can compare. So there are two vectors, say x and y, in an inner product space, and orthogonal vector says that the inner product should be equal to 0. Okay, so x perpendicular y if and only if inner product of x comma y is equal to 0. What is orthonormality? If two vectors x and y are orthogonal, that means the inner product is 0, and both have the unit norm, that means magnitude is equal to 0, then they are called as orthonormal vectors. All right, so without any further delay, let us take one example to understand. So let us take the two vectors in the form of matrix. Say x is equal to 1 comma 0 and y is equal to 0 comma 1. Always remember, when you are multiplying the inner product in terms of matrices, the x comma inner product of x comma y will be always x transpose y. Okay, so I made an error. It is inner product of x comma y. So if I take x transpose is 1 comma 0 and 0 comma 1, if I take the inner product, I will get the answer as equal to 0. Okay, it is equal to 0. It is equal to 0. Now I will try to find the orthonormal. What does it say? It is the norm of x should be equal to 1. That is what, 1 square plus 0 square is equal to root of 1 is equal to 1, and norm of y is what, 0 square plus 1 square, it is root of 1 is equal to 1. So I can say that these vectors are orthonormal because the dot product is equal to 0 in case of orthogonality, and in case of orthonormality I am having the norm as equal to 1 in both the terms. And always remember why I have written the inner product of x comma y as x transpose y. So actually the formula for, there is one more formula for finding the dot product in terms of matrices, that is x comma y inner product is equal to x transpose into a into y, where a is the matrix. Okay, a is a matrix, and you have, this is the formula, please remember. So you have to find the matrix. If you have the matrix, then you have to find the transpose of that matrix, and then you have to calculate the you have to multiply and then you have to calculate. All right, so now we will take one example, and let us try to solve one more example, and let us dive into it. So the example is as follows. Say x is equal to let me write it down. X is equal to say it is 1 by root 2 into 1 by root 2. This is a matrix, and y is equal to, say, one more matrix. It is 1 by so it is a one row one column matrix, right, and 3 rows. So I cannot multiply them each other, so I have to make it sure that I have to apply x transpose y. So if how to check for orthogonality, I have to apply x transpose y, right? So and the dot product should be equal to 0, right? So what is a formula? It is inner product of x comma y, x transpose y is equal to what? It is 1 by root 2. So 1 by root 2, let me write it down. Yep, it's sorry, yeah, 1 by root 2 into 1 by root 2 0 into 1 minus 1 by root 2, 1 by root 2, 0. So I have to multiply now, so I'll get the answer as equal to 0. I'm directly writing it. Please pause the video and solve for it. All right, so yes, now next thing is I can say that, okay, the dot product is 0, then I can say that it is orthogonal. Then how do I check for orthonormal? I have to find the norm. So what is norm of x is equal to, it is x transpose of x, right? Two terms, x transpose of x. So what I will get, it should be x square, right? So I can say that it is 1 by root 2 the whole square plus 1 by root 2 the whole square plus 0 square. So I will get the answer as it is 1 by 2 plus 1 by 2. Yes, 1 by 2 plus 1 by 2 plus 0, right? by 2 plus 0, I'll get the answer as sorry 1, right? 1 root of 1 is always 1, so I'm writing it directly. So what is norm of phi? Norm of phi is again so it is y transpose y. It is what it is minus 1 by root 2 the whole square, 1 by 2 the whole square, root 2 the whole square, and it is 0 square. So similarly I'll get the answer as 1. So that is all. I hope you understood what is the difference between orthogonal and orthonormal. Thank you.